Hey everyone, it is Stoltz from Stoltz-World. Welcome to Math on Demand. Unfortunately, I'm going to be out a couple of days here. I'm on campus, but I've got a couple of interviews that I have to run. So today, I'm going to take you through the couple of concepts that I'm going to set you to work on some problems while the sub's here. So your job is to watch the video. Your job is to take some notes. Your job is then to try some problems. You can see here on the screen already, I've kind of already highlighted the questions that I think you should definitely do. Now, obviously, you can always do more than that. That's always an option. And as an extended math student, I'm going to guess that that's probably something you already do. Right, Leo? Right. Okay. So today we are going to talk about two concepts that are really closely related to each other. It's the axis of symmetry and the vertex of a parabola. So I want to start by looking at this parabola right here. Now, every single parabola has a line of symmetry. They have horizontal symmetry, is what we call it. And the horizontal symmetry means that there is a magic line right here where, if we can kind of think that line there, if I took the right half of the parabola and I flipped it over that line, it would fall directly on the left half. That's what it means to be symmetrical. Interestingly, in general, human beings look for symmetry in life. Like, the more attractive someone is, the more symmetrical their face is. That's why when you look at me, like, super, super symmetrical, that's why I'm so hot. Anyway, here we go. So what our job is oftentimes we're asked to find the axis of symmetry. When we do that, we have three options. Option number one, to find the axis of symmetry, um, is just the average of the roots. So if we find the zeros or the roots and we just take the average of them, that's where the axis of symmetry will be, because it has to be exactly halfway in between. So if we know one of the values, all we have to do. So if I look here, I have one root at 10 and one root at negative 2. So if I do 10 plus negative 2 divided by 2, well, 10 plus negative 2 is 8, divided by 2 is 4. So my axis of symmetry is the line x equals 4. That's pretty straightforward and simple. Option number 2. You notice that the axis of symmetry runs directly through the vertex. So if we can find the vertex, we have the axis of symmetry. Well, here I've already graphed it, and you can see that it's 4. But if I was to take this equation, which is right here, I've already written down, I have the equation because I did this on Desmos. If I take this equation and I complete the square, what will end up happening is, by completing the square, I will find the axis of symmetry, because I'll have written it in vertex form. Vertex form is the form where it's a times x minus h squared plus k, where h, k are the coordinates of the vertex. So if I just want the axis of symmetry, then all I actually need to find is it's going to be x equals h. Okay? So if it's in standard form, like this one happens to be, all we have to do is complete the square. So let's just go ahead and do that. So we've got negative 1/2 x squared plus 4x plus 10. All right. Well, in order to complete the square, the coefficient on x has to be 1. So I need to divide everything by 1/2. And if I do that, I would end up with, actually, I'm going to divide by negative 1/2, because that will make my life easier. and that gives me x squared. Well, 4 divided by negative 1/2 is negative 8x, because when you divide by a fraction, it actually makes it increase. And then that 10, I'm not going to deal with the 10 right now. Again, my preferred method of doing this is always only to factor the first two parts. You don't have to, but that's how I like to do it, so that's what I'm going to keep doing. I have plus 10 is 0. Okay. Now to complete this square, I'm going to have negative 1/2. I'm going to pull my x down, and then I'm going to divide the coefficient by 2. So that's going to give me minus 4 squared. And then we have plus 10, but we have to remember I have subtracted 4, or I've added negative 4, but when I square that, I'm actually adding 16 to this. So I have to take away 16 from the whole thing. But I have to remember with that negative 1/2, while I'm minusing 16, what I actually need to do is add 16 to this. So after I've completed the square, I would end up with negative 1/2 x minus 4 squared plus 26. And if I go back up and I look at this, I screwed something up. What did I screw up? Divide by 2. That should be 18, and it's not 18. Oh, because I have to take half of it. Haha, good job, Stoltz. Half of 16 is 8. Sorry, plus 8. So that should be 18. There we go. I've completed the square. We have that. So now all I need to do to find the axis of symmetry is this is going to turn into x is the same as 4, which is again my axis of symmetry. Okay, there's one more way of doing this, and this last way of doing this is often the easiest way of doing it. And that is that we have a really handy dandy formula for this. And that formula is the axis of symmetry is going to be x equals negative b over 2a. And that refers to the ax squared plus bx plus c. So if we can remember that formula, I give that formula to you on assessments, you get that formula in the IB program, then you can take anything that's in this form here, and finding the axis of symmetry is really simple. So again, when our equation was negative 1/2 x squared plus 4x plus 10, well, negative b would be negative 4 divided by 2 times negative 1/2. Well, half or negative a half of 2 is 1, or negative 1, sorry. And 4 divided by negative 1, so this is negative 4 divided by negative 1, would just give me x equals 4. And as we can see, all three of these ways, despite some original difficulty on my completing the square, get us the same value. And looking at it graphically, that's what it is. Now, the only other bit that we need to talk about here is this idea of the vertex itself and how we can find the vertex. Well, I think you probably have a pretty good idea of how we can find the vertex from this little example here, right? We can find the vertex just by completing the square, and it'll give us our vertex. Super easy. We can also find the vertex by taking the average of the roots, and then after that, evaluating the function at the axis of symmetry. So if I know that the x-coordinate So if I know the x-coordinate is 4, then I just have to evaluate this function. Plus 4 times 4 plus 10. Well, negative 1/2 of 4 is negative 2. And 4 times 4 is 16. And then, do I not have my equation correct? I think I don't have my equation right. Right. So, Stoltz, what are you doing to yourself, brother? That would give me 24, and that ain't 24. What has gone wrong? Because I didn't square that, because I am not thinking straightly. All right, so this turns into negative 8. I'm sorry. So I get negative 8 plus 16 is 8, and 8 plus 10 is 18. So the coordinates of my vertex are at 4 and 18. That's doable. And again, we can do the exact same thing just by pulling this one in. I could also find because my vertex is going to be x, and actually my coordinates, my vertex is going to be the coordinate, the x coordinate, and then the function evaluated at that x coordinate. So I could really do this as, I could write this as negative b over 2a, and then f of negative b over 2a. And that will give me the coordinates of my vertex every time, super simple. Now, again, I need you to go and I need you to try this. This might seem simple. It might seem like something, oh, I don't need to practice. Practicing it will make sure that this skill sinks in. It'll make sure that you can do what we need to do next, which we will be doing shortly, okay? So I hope that's helpful, and I look forward to seeing you next time. Again, problems you're trying. Exercise 20D, you're doing 1A and F, 2A and F, 3A, B, F, H, I, and then on 20E, 1A and E, 2A and G, 3A, B, and F. With that, I think you are dangerous enough to get to work. Have a good one.